Okay, so let's finish up this section 4.7 on inverse trig functions. And we've talked about how to compose a trig function and its own inverse. But let's talk about how to compose two separate trig functions and a different inverse. Okay, so what we're going to do is kind of combine everything we've learned. Everything we've learned about inverse trig functions, right triangle trig, what we know about our quadrants. So we're putting it all together in this part of the lecture. Okay, so it says use a sketch to find the exact value of each expression. So this first expression is cosine of sine inverse of 24 over 26. Okay, before we move on and start this problem, remember, this is an inverse trig function. What is always the answer to an inverse trig function? It's an angle. So this problem is really just cosine of theta, but we have to use this to figure out where theta is. Okay. All right, so the first step is noticing that theta is defined by sine inverse. So we have to think about, okay, what is the range of sine inverse? Negative pi over 2 to pi over 2. So that tells us where our angle is going to be. So theta is in the interval from negative pi over 2 to pi over 2 because it is defined by sine inverse. That's the first thing we know. The second thing we know is that we can rewrite this. All right, so remember, we're given that theta is sine inverse of 24 over 26. Well, we can rewrite this using its inverse, so we can use the form we're used to. Sine theta is 24 over 26. Okay, so tell me, our angle, the sine is positive, is that going to be in quadrant 1 or is it going to be in quadrant 4? Where is sine positive? It's going to be in quadrant 1. All right, so our third step is to draw our triangle in quadrant 1. Here's our angle. We know sine is opposite over hypotenuse. So this is 24, hypotenuse is 26. We can use the Pythagorean. So x squared plus 24 squared is 26 squared. X squared is 100, so x is positive or negative 10, but we're using length, so we're going to go with positive 10. So now we have our triangle. So all of this was background work for the main event, so the problem we're actually solving, cosine of theta. That's what we're trying to solve, cosine of theta. So now, can we find cosine of our angle? Of course we can. It's adjacent over hypotenuse. And so this would be our final answer. If you would like to reduce it, that is fine as well. All right, so it looks complex and it has multiple parts, but they kind of flow together really nicely. And we're going to do a few examples. So let's do another one. This time we have tangent of cosine inverse of negative 10 over 26. So remember, cosine inverse is going to give us an angle. So remember, this is theta. This is our angle. So we're really just finding tangent of theta. But we need to use this to figure out where our angle is located, right? So we know what's positive and what's negative. So the first thing, where is our angle going to be located? Well, we're using cosine inverse. What is the range of cosine inverse? It's 0 to pi. Okay, so that tells us we're going to be in quadrant 1 or quadrant 2. All right, so we're going to rewrite this. So remember, our angle is cosine inverse of negative 10 over 26, which means that cosine of theta is negative 10 over 26. What quadrant is that going to be? Where is cosine negative? Quadrant 1 or quadrant 2? Quadrant 2. So when we draw our picture, we're going to make sure we draw our triangle in quadrant 2. Alright, and so we're given cosine, so we know adjacent, that's going to be our negative 10, hypotenuse is 26, we can find our y value. Alright, so I'll spoil it for us, the answer is 24. Which we knew from last time. All right, so y equals 24 right here. Okay, so that is all. That's everything we need to answer our question. All right, and remember our question is tangent of theta. So what is tangent theta? Well, we know how to use our triangle to figure out tangent theta. It's opposite over adjacent. And we're in the second quadrant, so tangent is negative. So negative 24 over 10, or if you want to simplify, it doesn't matter. Negative 12 over 5 if you want. Okay. All right, let's work the last one. So let's do secant of sine inverse of negative 1/6. Okay, so same process. Sine inverse is going to give us an angle. So we're really trying to find secant of theta. But we use sine inverse to understand information about our angle, like the location. Alright, so since we use sine inverse, we know our angle is between negative pi over 2 and positive pi over 2. Alright, so we can now rewrite the problem. So theta is sine inverse of negative 1 over 6, which means that sine theta is negative 1 over 6. Okay, so now we know exactly where to draw this, right? So this tells us we're in quadrants 1 or 4. Sine is negative, so that tells us we're going to be in quadrant 4. Okay. So sine is opposite. Oh. Maybe I just want to use, no, that's fine. Opposite over hypotenuse. You can use positive or negative numbers and just figure out what it's supposed to be at the end if you want. Alright, then we're going to use Pythagorean to help us figure out the other side length. So x is the square root of 35. All right, now we can answer the question. So this is my step 4. Secant of theta. We know exactly where our angle is. So secant is hypotenuse over adjacent. Is this supposed to be positive or negative or what? Secant is positive in the fourth quadrant. All students take calculus. C goes with secant and cosine. So positive 6 over root 35 is our final answer. All right, so at the end of this section, make sure that you can do these things. Can you evaluate the inverse trig functions for sine, cosine, and tangent? Can you solve trig equations using inverse trig functions? Can you find the composition of a trig and inverse trig functions? So this is a lot, so make sure you can understand these things.